Continuing our work here, we found these critical values using Excel, and now we need to make a decision. And the answer is we are totally going to reject H naught. Reject H naught because, oops, I better put in an H naught here. H naught. Because the test statistic, which is T0, it's here. Hold on one second. Why retype it all when you've got it right there? That's what I wanted to know. T0, which is 5.456, is in the critical region, i.e. larger than 2.0395, which is the critical value. Okay, so that's step 5 classical, that's step 4 classical. Now, how would it change for a p-value method? And of course, remember, p-value methods tend to be easier because computers find them more easily for us. But namely, StatCrunch finds it really easily. But let's do it again. Okay, so the p-value method, the graph looks similar, but it's not the same, just like before. They are going to be different from each other. Here we go. So let me draw, you know what? I'll be right back. I'll draw this picture. I'll be right there. There it is. Okay, so this value over here, this critical value, or excuse me, a critical value, this test statistic is 5.456. Then its opposite is also 5.456, but it's negative. And then the p-value is the area in both tails put together. And again, we're going to need to find that with Excel. So let's find this out. T.dist.2t, because this is a two-tailed test. If it wasn't, I would pick, just so you saw them, that's a left-tailed one, just the t.dist, and that's a right-tailed one, rt. But this is .2t. And then it wants x, which was 5.456, comma degrees of freedom, which is 32 take away 1. And remember that before we learned that if that was a low number, if this had been negative 5.456, you would have had to do absolute value of that number. You can do it now too, it won't hurt it. Okay, now that looks really big, but remember this is the p-value. What's happening is that that's scientific notation. It's really 0.000058, right? 0.000045558, right? That's what that is. Really low, in other words. If you have old school Excel, hold on, take me a second. It's oh goodness, T-dist. Yeah, that's it, T-dist. And then you tell it that x, and I think again you have to do absolute value, not because it wouldn't work for this particular one, but because it wouldn't work in general. Degrees of freedom is 32 take away 1, tails would be 2 because it's a two-tailed test. There you go, same number. Okay, so new school Excel, old school Excel, either way it can work. All right, what about StatCrunch? Because we know that we tend to like StatCrunch a little bit better, at least I do. Hold on, let me bring it up. Okay, here's our data, students and no and yes, and the difference that we found. So you can do stat, T statistics. Okay, we're doing a paired data set here. See that? Paired. And it's going to say, what's your sample? So it's going to take sample 1 minus sample 2. We wanted yes to be the first sample because that was the one we did first. So we're going to take the yes minus the no. Technically, we could do a 1 sample 1 with the difference column, but whatever. And then we hypothesize the difference is 0, and it's a not equal to test. We can calculate. And look, there you go, 5.456, just like we said it was. And see, the p-value is less than 0.0001, which it is, because it's what we found over here. This value is less than 0.0001. So there, that's how to do it in StatCrunch. Really nice and easy. Okay, so then... hold on, I gotta bring my graph back up. There it is. So we just found this p-value to be less than 0.001, 0.0000058. Okay. And there it is, copied and pasted into the table. All right, I'll meet you back here to finish this problem, and then we'll start the confidence intervals.